Hey, so welcome back, and this is another LeetCode problem. So today we're going to do a question called Rearrange String, k distance apart, and it's question 358 here. And so it's a hard level LeetCode problem that we're going to use a max heap as well as a queue for it. All right, so there is actually a medium level problem that's much simpler than this, and it only needs the max heap. It doesn't also need the queue. And I'll add that link to that problem in the description below if you want to try that one before you do this one. But hey, if you want to go ahead with this hard level problem, let's get started. So I'll first do the whiteboarding and then I'll show you the code solution. So the first thing here that you have to understand is we're given this string here, and we have to make it such that each of these letters here, each occurrence of the next instance of the same letter should at least be k distance apart. And so I'm assuming you already know this example, but the example they show you, you have 3 A's followed by 2 B's and then 2 C's. So if we write that out here, it's 3 A's, 2 B's, and then 2 C's here, okay? And so we want to rearrange this such that these letters, or the occurrence of the next letter, is at least 3 spaces apart. And so this is the output that we would expect here. And so it has such that A, and then we do B, C, so that the distance between this A and then the next one is 3 spaces apart, as well as B. So B is 3 apart from the next occurrence, and then C is 3 apart from the following occurrence. And so one thing that I kind of said, okay, this is kind of an edge case here, is that it really feels like it's only 2 apart. So when you see 3, it just means it should be kind of 2 letters away plus the next occurrence of it. So I kind of think of it as k minus 1, but if k works for you in your head, then that works fine. So the way you solve this problem is you want to use a max heap, and that's simply so that you can figure out and greedily say, I always want to be placing the letter that has the maximum number of occurrences. So you just want to greedily choose, okay, which letter do I want to use next? Let's use the one that has the highest number of occurrences, or the highest number of frequency to use next, okay? And so when we look at this, this is literally a dictionary here, and you can see that in this dictionary, the ones with a value, or I guess a key of 3, really, I guess this is inverted. So let's switch this dictionary around so that makes more sense. So A is the key with the value of 3, B is the key with value of 2, and then C is the key with value of 2. All right, and so in this case, what you can imagine is that, okay, we want to greedily choose whichever key has the highest value. And so we first want to place A in our string here. And so you'd have something like A. All right, and so following that, you would then want to choose, okay, how do I determine what to use next? Because once again, A can be decremented so that we only want to use 2 more now. But the problem is, okay, what about these 3 choices here? How do I move forward from here? Because we have 3 different options. Well, the way around this is to use a queue. And that's the really trick with this kind of k distance apart that makes it a hard level problem, is that unlike the medium level problem I'll add in the description, we need to actually track using a queue what are the following keys that we can consider next that is actually that k distance apart. And so whenever we use a letter, we will then insert into our queue here. So I'll just write out queue. And so in our queue here, and we will add to the front of the queue basically a 3 different cases that we care about. The first thing is, okay, we care about the letter, so A, then the number of occurrences, which is 2. We want to add 2 left here, but then also the last thing here is that then we also want to signify what was the index that we placed it at, which is 0. Okay, so we place at index 0 of our string here, okay? And so then we can always look at our queue and consider in the next upcoming case, okay, do we want to re-add this to our max heap? And we know that we can add it to our max heap again as long as the index, because once again, this is the index, is at least k here, k, so k equals 3, distance apart from our current position. Okay, so is this index that we put to our queue at least k distance apart from the current index? If not, we don't want to consider it. Okay, so let's keep moving forward from here. So then we kind of remove this from our options. We can't use A anymore because it's on our queue. And you can imagine this as our max heap right now. So we would essentially be taking this dictionary, and then we're essentially just going to do a heapify function, and we would output a max heap here, okay? And it might make more sense when we look at the code, but it's really important that you understand the algorithm here, okay? And so from this point on, we want to do from A, so let's use B arbitrarily next in our max heap here, so let's add B, and then we'll essentially be adding B to our queue here, okay? So then from here, behind our queue, we'll have a B, and it has a one more occurrence that we want to use left, and that index 1. So this is kind of added behind our previous value in our queue. And then once again, do we want to consider re-adding what's at the front of our queue? No, because we're now looking at the following index 2 here, and unfortunately the index 2 is not k distance apart from 0. It's not 3 distance apart, it's only 2 apart. Okay, so now we can't use B anymore. We can reconsider and say, okay, let's pop from our max heap, and that's going to be the value or the letter C here. And so we add C to our output string. But once again, now our max heap is actually empty right now. And so what we're going to do is we can look to our queue and say, okay, our queue now has C. We want to add one more frequency to it, and then it's at index 2 here. And so we're saying, okay, let's look at the front of our queue. This is the front here, and we can say, oh, now we're at index 3, which is k distance apart from the previous occurrence of the letter A here. And so once again, we can actually add A back to our max heap. So let's pop left or kind of dequeue from our queue here. And so now this is the new front of our queue, which is B. And you can imagine on our max heap, we've kind of re-added A to our max heap, and it has a value of 1 here. And so now we can use A and kind of heap pop from our max heap and put A back here. And so from here we can say, okay, there's nothing left on our heap. We can look at our queue. So from here, okay, is the current index, which is at 4 here, k distance apart from the previous instance of the front of our queue? It is, because 4 minus 1 is equal to 3, which is our k. And so we can add B back to our queue here, so we can reconsider it. And so now B is at 1. And so we pop from our max heap and we put it here. Once again, that's off of our queue because we dequeued it. We look to our queue, we can add C back to the max heap. C is now 1. And so once again, we add C here, and we can see that there's nothing left on our max heap. There's nothing left on our queue. And so this is our output, and it is actually a valid output. Okay, so this is the whiteboard solution. I'll now go through the algorithm, and I think it'll make a lot more sense. All right, see you in a second. So welcome back, and we're going to code up our drawn solution here. And so once again, this is question 358, and we're going to implement it. And so the first thing that we want to do is we want to define our output string, and we're expecting to return this at the end of our algorithm. And so from here, we want to say, okay, let's go ahead and define our queue, which is as simple as just grabbing from the collections library, and we'll use the double-ended queue here, and it's initially empty. We also want to generate our max heap. And so we're going to do the exact same thing that we did here, where what we had is okay, this is our dictionary where we have a mapping of the letter and the number of occurrences of that letter in our string. And so we can easily do that by using the counter library like so counter, then we just pass in our string here, and that basically outputs a dictionary that looks like A has 3 occurrences, B has 2, and then C has 2, like so. And so with that, we want to actually create our max heap now. And so to have that happen is we want to say, okay, let's define our max heap. and then we'll essentially call the heapify function on it so that it can uphold the properties that we're looking for. And so from here, what we can do is we can grab an iterator from our dictionary here using counter.items to return basically every key and every value in this dictionary. And so we just want to create this array that looks like so basically, keep doing it here, is we're saying, okay, we're going to have the negative value corresponding to the key. And the reason why we negate the sign here is that because there's no max heap in Python, there's only a min heap. The way around that is by negating the value. And then we just put the key here, and that's just because when we sort or heapify this array here, we want to sort it by the value and not the key, okay? And so that way that at the top of our heap, whenever we're popping from it, we're always going to be popping the highest number of occurrences first, okay? Because that's what we want to use next. And so from here, we want to keep going while we have something on our max heap here. And so the way we do this is we want to say, okay, we always want to be popping off and using the thing that has the highest number of occurrences next. And so we can say, okay, let's look at whatever key is at the top and also the value. So we'll just call this key and value. And so we get this by popping off from our max heap. And so from here, what we want to do is we want to simply add that key to our resulting string, as well as because we just used our max heap, we have kind of a wait time of k. And so we want to add that to our queue so we can wait k iterations before we use it again. And so to do that, we just say, okay, if the value +1, and it's +1 because, well, it's been negated, if that is equal to 0, basically we've run out of uses for this and there's no point in adding it back to our queue because, well, basically we've used the 3 occurrences of this letter A and there's no point in adding it back to our queue because we can't use it anymore. But if this is not the case, and I guess what we'll do is negate the sign, then we actually want to add it to our queue. And so we say, okay, let's go ahead and add to our queue this particular key with this particular value +1 because we used 1 occurrence of it. And then with that we say, okay, and this is the current position of this previous use. And so it's going to be basically the length of this string -1 because it's 0 index. And so we want to return the index of this use of this letter in the current string. And so from here, this is basically like, let's use this key. And then from here, all that we want to do is move forward and say, okay, can we re-add from our queue to our max heap? Okay, so can we take now something that's on our queue because it's been kind of k distance apart, so we can kind of use it back on our max heap again. And so we'll check that. So first thing that we want to do is say, okay, if queue, like do we even have something on our queue? And if so, well, let's take a look at those values so we can take a peek at the front of our queue like so. And so we want to grab basically the queue key, the queue value, and then also the queue index like so. And so now we can say, okay, well, are we able to reintroduce this value from this queue back onto our max heap? Well, that's only the case if it's k distance apart. And so what we want to do here is we say, okay, we want to basically add to our max heap, so heapq.heap push some value if it meets some case. And so let me just think here. So if the current length here minus k is basically greater than or equal to the use of the previous index, right? And so say if the length of the string is 3 long and we need at least 3 apart here, and so that could look like something like this, where it's basically A, B, C. We want to see, okay, can we add basically A from our queue back onto our heap? And so yes, because k is equal to 3, so we can add it here. like so. All right, and so if that's the case, then we can actually push from our heap there. So we want to add an if statement here as well. And so with that, we can say, okay, we want to push to our heap, and it's going to look like a tuple where it is the q value, as well as, and let me just think here, the particular q key here. Great, and so I think that is pretty much it. The only other edge case here is that, okay, well, we also want to say, okay, we want to return the response as long as it actually matches the length that we're expecting. It's just a small edge case here. Otherwise, we know that we weren't actually able to use all the things onto our queue, that's on our queue. Like there's still something on our queue that we weren't able to actually use. So if the lengths don't match, then we weren't actually able to construct this rearranged string with k distance apart. And so with that, I think everything's right here. Let's try running this. Oh, expected, but got 1. Heap q.heap push. So we want to push to what heap? Let's go and be heap. Let's go to our max heap here, like so. So it looks like it's still running. I think it's going to get a time limit exceeded. So these are our queues, these are our values. This is pushing to our heap. The only other thing here is we want to actually remove that. Here we're just peeking at our heap or our queue. We actually want to remove it from our queue. So we can do queue.pop left. All right. Sweet. Looks good. And success, so it just ran successfully, and it's a pretty productive algorithm. So yeah, I hope that helped a little bit. I hope the whiteboarding was useful. So the main core of this algorithm was we wanted to use a max heap, so we can always be using the letter with the highest number of frequency or the highest number of occurrences next. But then also we want to use a queue so that we can actually maintain this constraint of we want to be k distance apart. So whenever we found that the front of our queue is actually now k distance apart, we want to reintroduce it to our max heap again because we can consider it again, and we just continue popping whatever is the highest number of occurrences from our max heap. All right, so hope it helped a little bit, and good luck with the rest of your algorithms. Thanks for watching.